Okay, 11, 12, and 13. So we're going to have one question on the wave properties of light and matter, one question on de Broglie theory, and then 2 questions on Rydberg. Okay, so wave particles of light and matter. The famous electron diffraction pattern is proof of what concept? Remember, I told you to remember that diffraction gave particles wave-like properties. Particularly the electron, which is matter. What gave the location is quantum mechanics for location and trajectory of electrons. And then, yep. Moving on to question 12. According to de Broglie, which of the following has the smallest wavelength? Remember, de Broglie's equation says wavelength is inversely proportional to a mass. So the bigger the mass, the smaller the wavelength. The smaller the mass, the bigger the wavelength. So we want the smallest wavelength, which is this scenario. So the one with the high. So we have electrons, neutrons, protons, and molecules. Well, electron is the smallest, so that's going to go. We want a big mass for a small wavelength. Neutrons and protons are the next smallest, and then molecules are made up of many of those. So molecules will have the highest wavelength. Now we're talking about the Rydberg equation calculation. Which of the following transition emits the highest energy photon? Remember, the lower you are, the higher the energy. The lower you are, the higher the energy. Okay? So a transition from 2 to 1 is going to be greater than a transition from 3 to 2. If we look at electron transitions, not this, you'll see that the gap between 2 and 1 is a lot bigger than the gap between the top ones. So 2 to 1 has a greater energy than 3 to 2, meaning it has a smaller wavelength. So highest energy would be from N, 2 to 1. They're not asking about wavelength. If it was wavelength, it'd be the opposite.